So in this tutorial we are going to study about the queues data structure, and similar to stacks we will implement queues using arrays and linked list. So just like stack follows a principle, the basic principle behind stack is the last in first out, the LIFO data structure. And the queue data structure also has a principle, and this principle is the Fifo principle, and Fifo stands for first in first out. First in first out. So this first in first out principle basically means that the first element inserted inside the queue is going to become the first element to come out of the queue. So if you are inserting an element in the queue, then it will become the first element to get out of the queue. So this is the basic idea behind queue. So let me just give you a real life example of queues which we all have seen in real life. So let's suppose there is a ticket counter and there is a man sitting here, and let's suppose there is a formation of line which we are calling as queue. So let's suppose there are people who want to buy these tickets and they have formed a line. So in this formation, the first element inside the queue is going to get the ticket first. So this you can say this concept is known as the first come first served basis. First come first served. And this concept, first come first served, you're going to use this concept in computer science a lot of times, like our operating systems, and you used to perform some scheduling operations using this concept, first come first serve. So we will use this concept, first come first serve, in advanced computer science topics. So the basic idea of queue says that first in first out principle. So this means that the first element that you are going to insert in the queue is going to come out of this queue first. And the basic application of queue is the first come first serve basis, which is also known as FCFS. So let's suppose a new man wants to get added in this queue. So this man will have to follow a particular the rule of insertion, which says that this man will get inside this queue only at the last position. So let's now apply this real life concept in computer science. So let's suppose we have an array with some elements inside it. So initially I'm not going to insert any elements, and we can see that insertion is going to perform at the end and deletion is going to perform at the front. So you are going to use two variables, front and rear. So we will use the front and the rear variables to access the particular elements and insert them or delete them from this queue. So insertion inside the queue is also known as enqueue, and deletion from the queue is known as the dequeue function. So in the implementation part, we are going to write these two functions, and these two functions manage these two variables, and these two variables just signify the positions of performing these two functions NQ and DQ. So initially when our DQ when our queues is empty, so the value of front and rear will be null. So let's suppose we have some elements that we want to insert in this queue. So let's suppose the elements are 2, 3, 4 and 5. We're going to take these 4 elements. So let's see how the values of front and rear will change when we are going to NQ or DQ from this queue. So let's suppose we are going to perform an NQ function and we are inserting or NQing 2 in this array, or now you can call this array as a queue. So we are going to NQ 2 in this queue. So we know that the index position starts from 0 and it goes on like this. So indexing starts from 0. So when you are going to insert the first element inside the queue, the value of front and rear will be equal to 0. So 2 will get inserted here. So after the first call of the NQ function, the values of front and rear will get changed to 0. So both of these variables are going to point to the 0 position of the array. So let's suppose now we want to NQ 3 inside this queue. So let's see how our array or how our queue will look like after the insertion of 3. So 2 is already there and these are the index positions. So now after insertion, the value of the rear will get increased by 1. So one important thing to note in the NQ operation is that in case of NQ, we are going to increment the rear position by 1. So I'm writing here rear plus 1. So in case of insertion, we will just increment the value of rear. So front will point to 0 while rear is going to point to 1. And then we will insert the element at the rear position. So you can see here. So whenever we want to insert an element inside this queue, we are just going to increment the value of R, which is rear. So we are going to increment rear to delete a particular element from the queue data structure or from this array. So let's now see what will happen in case of a DQ function. So let's suppose now we are going to perform a DQ function and we are going to DQ 3. So the only choice in DQing is that you will have to push out the element or you will have to perform the DQ on the front end. So the last, you can see that this element, if you want to perform the DQ of 3, you will first have to remove 2 and then you will have to remove 3. And the reason behind it is that the first element inserted inside this queue is 2. So it is going to become the first element to come out of this array. So I'm going to write here DQ operation, and I'm not specifying any number because DQ will start from the front side, and thus we are not writing any particular element. So let's suppose I have called the DQ function. So let's look how the values of front and rear will become after this operation. So now the stack will be the same, but the value of front will increase by 1 and the value of rear will be the same. So you can see that before the call of the DQ function, front was pointing to 0 and rear was pointing to 1. So if we will call a traverse function that goes from front and traverse along this array till the rear element or the rear position, then if we want to perform a DQ function, we are just going to increment the value of front. So now our traversal will start from this element and thus it will disregard the first element or the element that is inserted first inside our queue. So that's the main reason why inside the DQ function we are going to increment the value of front by 1. So the most easiest way to learn this concept is that in case of the NQ function we are going to increment the rear value, and in the case of DQ function we are also going to increment the front value. And the concept is clear by this diagram. You can see that if we will increment the value of front, the traversal will start from the next element, thus this element will get disregarded. So you can see that 2 was the first element that we have inserted in our queue. So it will come out of this array first. So this is the main concept, the main principle of the queues. So in the next tutorial we are going to use the array implementation, and we will implement queues, and we will implement these two functions and also the traverse function to traverse in our queue. So thanks for watching.